Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about dynamic programming algorithm design technique, which is belongs to module 15. So here in this module, we are going to discuss about two applications of dynamic programming. The first application is Knapsack problem, and second application is Bellman-Fold algorithm, which is used to solve single source shortest path problem. So as part of today's session, we are going to see knapsack problem and memory functions. So first of all, we are going to see what is the problem statement, knapsack problem statement. So you already well versed with the knapsack problem statement. So we know that we have two types of knapsack problems. One is 0/1 knapsack and other is fractional knapsack. So the fractional knapsack problem can be solved using greedy algorithm design technique, whereas 0/1 knapsack problem can be solved using dynamic programming, right? So here we are going to solve a 0/1 knapsack problem, right? Now here, let us see the problem statement once again. So what the inputs that are given for us in this problem? So you are given with n objects. Let us say those n objects are x1, x2, so on, xn. And here each object xi is associated with a weight wi and a profit pi. You are also given a knapsack with capacity m. So if an object is placed in the knapsack, then its profit can be gained. Now here the 0/1 knapsack problem is to place the objects into knapsack in such a way that the total weight of the objects placed in knapsack is less than or equal to the capacity of knapsack, and total profit earned must be maximum. So here the value of xi can be represented as 0 if object is not considered to place into the knapsack. The object value is represented as 1 if the object is completely placed into the knapsack. And here the fractional values are not allowed since this is 0/1 knapsack problem. And here the optimization function here is profit should be maximum. That is sigma I is equal to 1 to n pi xi should be maximum always. And this maximum profit can be achieved within the capacity limits. So that is sigma I is equal to 1 to n wi xi should be less than or equal to the capacity of knapsack, which is nothing but m. Right, this gives the problem statement. Now, how we are going to solve this knapsack problem in dynamic programming? The recurrence relation that we use for solving this problem. So here we know that in dynamic programming, the problem is divided into subproblems. So we can write a recurrence relation of the solution procedure. Now here, this is the recurrence relation that we use for solving this particular knapsack problem. So here in this recurrence relation, you can see that value of I comma j is equal to maximum of value of I minus 1 comma j comma vi plus value of I minus 1 comma j minus wi. So if j minus wi is greater than or equal to 0, here j is the capacity, wi is the weight of the ith object, and v is the value. V is the value, right? So if j minus wi, that is the capacity minus weight of ith object, is greater than or equal to 0, in this case, the value of I comma j, that is we are going to find a matrix-like representation. In that matrix, the element v of I comma j, that is value matrix, we are going to find the value in the value matrix. The elements can be found, or the entries can be found by using this one. So if j minus w of I is greater than or equal to 0, in this case, the entry becomes this one. Otherwise, if j minus wi is less than 0, the entry becomes this one. And we need to initialize, we need to use some initial conditions. The initial conditions are v of 0 comma j is equal to 0 for j greater than or equal to 0, and v of I is equal to 0 for I greater than or equal to 0, right? So these are the initial conditions that we need to take. Right, now we are going to see by using this recurrence relation, how we are going to solve this problem, how we are going to find that matrix. So here we are given an instance, so which contains 4 items, and the weights of 4 items are given as 2, 1, 3, 2, and the values of 4 items are given as 12, 10, 20, 15. and capacity is given as 5. Now we need to develop a matrix. So here in this direction we are going to take the capacity. So here how we are representing capacity is the maximum, since the maximum capacity is 5, we represented the values from 0 to 5. And here we have 4 objects. Totally here I have n is equal to 4. Since 4 objects are given, the 4 objects are represented from 0 to 4. So here every time we need to select one object, right? Now here, let us say, how we are going to fill these values using the recurrence relation. Now here, let us see, first we are selecting the 0th object. Since there is no any 0th object, so the capacity filled is 0 in the knapsack, as well as the object selected is also becomes 0. So all these values are to be represented as zeros in case of initial condition. That already we seen in the earlier problem. So here we seen that in our earlier slide we seen the initial condition. So which becomes v of 0j is 0 and v of I comma 0 is 0. So that initial condition I represented here. Next, what we are going to see is, first we are going to select the first item. First we are going to select the first item. Now when we selected the first item, the weight of first item is 2. The weight of first item is 2 and its value is 12. Now here the capacity is 1. Can I place the item with weight 2 in the capacity 1? No, I cannot place. So that's why here I am not placing this particular object 1. So its value becomes 0. Since I am not placing, its value becomes 0. Now the capacity is 2. Here the weight is 2. I can place a weight 2 in the capacity 2. That's why if I place this object in this capacity, I can gain a profit of 12. Now here the capacity is 3. In 3 capacity, I can place 2 weight. So that's why here also I can gain a profit of 12. So here also I can place. So a profit of 12 can be gained. Here also I can place. So a profit of 12 can be gained. So if I selected the first object, if the capacity is this one, I can place. If the capacity is this one, I can place. If the capacity is this one, I can place. And if the capacity is this one, I can place. Now I am going to select the second object as well. Now I am going to select the second object as well. Now let us see, the weight of second object is 1 and the value of second object is 10. Now here I am going to say the capacity is 1. In 1 capacity I can place this second object since its weight is 1. So that's why we can gain a profit of 10. Right. Coming to here the capacity is 2. So I can place 1 weight in the 2 capacity, but I cannot place both the items entirely. So that's why here you need to take the capacity. Here I can place this weight as well as this weight. Wait for 5 minutes. So here I can place the first object in this capacity as well as the second object in this capacity. So which gives maximum profit, that can be placed here. Out of these 2 objects, first object gives the maximum profit. So that's why we are placing the first object. And coming to this capacity, here the capacity is 3. Now the weight of first object is 2 and the weight of second object is 1. So total weight is 3. I can place both the objects in this capacity. So that's why I can earn a profit of first object as well as second object. So the total profit becomes 22. Now here also, here the capacity is 4. So that's why I can place both the objects. So I can earn a profit of 22. Here also the capacity is 5. I can I can place both the objects. So the capacity becomes the weight, the value that I can gain becomes 22. Right. Now here coming to the third object. So here the capacity is 1. I cannot place the third object since its weight is 3. Since its weight is 3. So I can place only the second object in this. So that's why its value that can be obtained becomes 10. So here I can place the first object as well as second object. Since the first object value is high, I place the first object. And coming to here, its weight is 3. I can place third object alone, so which gives a profit of 20. I can place second object alone, which gives a profit of 10. I can place first object alone, which gives a profit of 12. And I can place both first and second objects, which gives a profit of 22. So out of all those 4 combinations, which gives the maximum profit, the combination of these 2 gives the maximum profit. So that's why I can select first and second objects. And coming to this capacity, so here I have the capacity 4, right? Now, what the alternatives that I can have here? I can place the second object. I can place the first object whose profit that I can earn is 12. I can place first object whose profit that I can earn is 10. I can place both the objects with the profit 22. I can place third object alone, which gives a profit of 20. I can place second object and third object, which gives a profit of 30. I can place second object and third object, so which gives a weight of 4. So here capacity is 4. So that's why I can place both the objects, which gives a profit of 30. So that's why here we are selecting second object and third object. And coming to here, the capacity is 5, right? Coming to here, the capacity is 5. Now here, which objects can be placed here? So here you can see that I can place first object alone, so which gives a profit of 12. I can place second object alone, which gives a profit of 10. I can place first and second objects, it gives a profit of 22. I can place second and third objects, which gives a profit of 30. I can place the 3 objects. Sorry, I can place the first object and third object, which gives a profit of 32. I can place second object and third object, which gives a profit of 30. Now, out of all these, so first object, second object alone, 1, 2, 1, 3, and 2, 3. Out of these, which gives a maximum profit, 32 is the maximum profit. So we are selecting 1, 3, right? Now, here, if you see the fourth object, now which can be placed here? Let us see. In the first one. So here it is having a capacity 1. So I can place only second object. So that's why 10 is placed. And coming to the 2 capacity. So here in the 2 capacity, I can place the first object, which gives a profit of 12. I can place the second object, which gives a profit of 10. I can place the fourth object, which gives a profit of 15. So that's why, since this gives the maximum profit, here I am selecting only the fourth object, right? Now, coming to the next one, coming to the next capacity. So here, I can place first object alone, which gives 12. I can place second object alone, which gives 10. I can place 1 and 2, which gives 22. So I can place 3 alone, which gives 20. I can place 4 alone, which gives 15 profit. And I can place 1 is having 3. I can place second and fourth objects. I can place second and fourth objects, which gives 25 profit, right? I can place second and third. I can place second and third. It will not be possible to place second and third because the weight becomes 4, but here capacity is 3 only. That's why I cannot place this one. And so these are the possibilities that I have. Out of this, which gives the maximum profit, 25 gives the maximum profit. So that's why here in the capacity 3, I can select both second and third objects, right? Second and third object. Coming to this one, fourth one, so I can place the objects which gives 30. So that is nothing but second and third and 37. So here, since it is having 5, I can place first object, I can place second object, and I can place fourth object, which gives totally 37. This becomes the maximum profit. So that's why I can express the total solution as 1101 and maximum profit in at least 37 and occupied weight is or occupied capacity is 5. Like this, we can solve the problem. We can solve the knapsack problem using dynamic programming. But here you can see that unnecessarily we calculated so many subproblems. We solved so many subproblems. This is one subproblem, this is other subproblem, this is other, like that. We solved so many subproblems unnecessarily. So it takes more time complexity. If I solve like this, it takes more time complexity. That's why we are going for a memory function method which reduces the time complexity and which solves only the necessary problems, necessary subproblems which are useful for finding the final solution. So here, for the memory function method, we follow this algorithm. So here you can see the steps in this algorithm. If the value of I comma j is less than 0, we need to initially we need to initialize all the values with -1s, and if the value is less than 0, and we are going to check another condition, if the capacity is less than the weight, then we need to call the algorithm for I-1 and j. Else, if this condition is false, now we need to call the function for I-1 for call the function for the maximum value of I-1 comma j comma values of I plus memory function of I-1 comma j minus weights. Right. So here we are taking a maximum. Here directly we are finding the value from this function. Here we are taking a maximum value of these two functions. Right. Finally, Vij takes the value and we need to return Vij value. Right. So this gives the memory function algorithm for solving knapsack problem using dynamic programming. Right. Now how we are going to solve this memory function problem. How we are going to solve this memory function problem. Right. See this memory function problem. We have taken the same example with weights 2, 1, 3, 2 and values V1, V2, V3 and V4. Right. So now it works in a top down way. So here we are selecting bottom up way. We are selecting the maximum value for I is 4 and the maximum value for capacity is 5. So that's why we are calling the function for 4 comma 5. So here you can see that we are calling the function for I and j. So here I represents the number of items and j represents the capacity. So here my number of functions is 4, number of items is 4 and j is 5. So that's why we are calling the function for 4 comma 5. So when I check the condition, so if we check the first condition, now here we are checking the condition, value of I comma j is less than 0. So initially we are taking all -1, all values as -1. So initially value of I comma j is obviously -1, since it is -1, since it is less than 0. So we go for checking the next condition. So which is nothing but the j is less than weight of I, that is weight of 4. Now here we are checking 4 is fourth item is whose weight is 2 and we are comparing that with weight. Now here the capacity is 5 less than 2 we are checking. Now here 5 less than 2 if I checked, so that gives the condition as false. So we are going for the else condition. So we need to call these two functions, memory function of this one and memory value plus memory function of this one. Right. I-1 comma j. I-1 is 3 comma j is 5. Here I-1 is 3, j minus weight. J is 5 minus weight is 2. That is 3. Right. I need to call this function. Now here you can represent the memory function of 3 comma 5, 15. Value I have taken. So here you can take the value of I. That value of I is 15 plus memory function of 3 comma 3. Now again the same algorithm is called. Now after calling this algorithm, In the bottom of way, we are going to find all these values. If I find these two values, the maximum of these two values is 22, that is assigned here. Now, if I find these two values, the maximum of these two values is 12, and that 12 is added to 20, so which gives 32. So here 22 and 32. So here I have 20 and its value is 12. 20 plus 12, which becomes 32. The maximum of these two is 32. And like that, we will solve the problem. And finally, we will get the solution as 37. So here, what the values we solved is only these values we solved. We didn't solve all these values. So we skipped the solving all these sub problems in memory function method, which saves the time complexity. So which saves the time complexity for solving the 0x1 knapsack using dynamic programming. Right. So I hope that you all understood the solving of this knapsack problem using dynamic programming, general dynamic programming method, as well as using memory functions method. So I hope that you all understand. Try to solve one more problem, then you will be well versed with both the methods. Thank you for listening. Thank you.